Hello class and welcome back to Sketch Science. Today we're going to be talking about a little thing I like to call kinetic and potential energy. Now, these might seem like review to you, might seem, why do I have to learn this? Well, every type of movement has one of these two things in it. Or lack of movement, for that matter, could still have one of these. Now, kinetic energy, we'll start there. Kinetic energy is the energy of motion. So, when you're moving, you have kinetic energy. It's calculated by finding out how fast you're moving and how much mass you have. Now, when you think about that, what does that mean to you? Well, if you're going faster, you're probably going to hit harder than if you're moving slower, right? So, going faster means you'll have more kinetic energy, because if you're not moving very fast, think about it. If you're walking at a slow pace and you run into a wall, oops, you bumped into a wall. But if you're moving real fast and you hit that wall, it's going to hurt, isn't it? Think about it. If this wall right here, we're sitting here, and you're running as fast as you can towards that wall, and you run in and bang, right into there, that's going to hurt. You're probably not going to feel too good afterwards. You're probably just going to be laying on the ground in pain. Just not having it that day. Meanwhile, if you just slowly walk into that wall, you'll probably just kind of walk away with your hand on your head like, man, I'm kind of dumb. But you're not going to be in pain. So, that's the idea of fast. The other one is mass. How much stuff you have in you. Speed, you all know what speed is. But mass is how much stuff you have. On Earth, that's also what you weigh, because we use Earth as kind of like the 1-to-1 mass to weight thing. But if you weighed 100 kilograms on Earth, that's like somewhere over 200 pounds. I use American units, so it's kind of hard to remember all the time on all the conversions. But your mass, 100 kilograms on Earth, is the same in space. So, on Earth and in space, your mass is the same. Meanwhile, your weight on Earth is 100 kilograms. In space, it's 0 kilograms, because there's no weight in space. You're just kind of floating out there, right? So kinetic energy uses both mass and speed. The reason it uses mass is because if you were in space and it based off of weight instead of speed, or instead of mass, you'd have no kinetic energy even though you're moving, which would make no sense. That's why it's based off of one, not the other. Now, kinetic energy, like I said, is motion. To find out your kinetic energy, you take half, or 0.5, times your mass, times your velocity. Velocity, the reason we use that instead of speed is because velocity is in a specific direction. It's a vector. It's one direction. Velocity is a straight line. It's always going in the same direction. Meanwhile, speed is just how far you traveled over how much of a time. So, speed can be any direction. It's just going, I went a mile in 10 minutes. That's your speed. But velocity is, if that was looping all over the place and you went that mile in 10 minutes, sure, that was your speed. But your velocity is, if you went in a straight line during that, how fast were you going at that moment? That's why I use velocity instead of speed for kinetic energy, because it's a snapshot in one direction. And you square the velocity, which means the faster you go or slower you go will have a bigger effect than how heavy you are. You could weigh half the weight of someone, but be going only a quarter faster and still hit just as hard, depending on how fast you're going. Now, let's do an example of this. So if you have a car or a bus in this case, if you are going 20 meters per second in this van, and this van weighs 1,000 kilograms, just over a ton, 20 meters per second in a 1,000 kilogram van, how would you write that out? Well, you probably start with the 1/2, as always. You start with your 1/2, multiply it by your mass. Remember, your mass is that 1,000 kilograms. It's how much stuff that van is made of. Then you multiply it by your velocity, your 20 meters per second. And you square that. Remember, velocity is squared. Now, if you take all those numbers and put them together, I'll give you a second to do that. Ready? Hope you had your calculator out, because that is 200,000 joules. Joules is the measure of energy. That's your kilogram meters per second squared. So, that van has 200,000 joules. That's your kinetic energy, your energy of motion. Now, your potential energy works a little bit different. Potential energy is an energy of position. It's not of moving, it's of position. You're not moving at all. If you were, that would be kinetic. Potential is all the energy you have if you're not moving. It's energy that could happen. It has the potential to happen, but has not yet. Potential energy can be caused by things like gravity. That's a Y. Gravity. It could happen based off of elasticity. Like a rubber band. It could happen based off of a spring. All of these things could give you potential energy. It's all things where you're in a position, and if something were to happen, that position would change due to you being moved. So that could be you falling. It could be you shot out of a cannon, an explosion, any of that stuff. All had the potential to move you, but once it does, that potential is now kinetic. It's now moving. Here's an example. If you were, and I know it's a very popular game, I think it's called like Spork Knife or something like that, but let's just say you built up this big tower in Spork Knife. You're going up. It's got like the flat pieces here going up. Got a flat piece here. You go up a certain amount, and you're standing at the top of this thing. You're standing up here. Your character weighs 55 kilograms. Well, you would have potential energy up here, right? Because potential energy is, once again, your mass. Think about that. Remember your mass. Potential energy is your mass times the force due to gravity, and we'll go over that in a second, times your height. So if it's mass times gravity times height, what does that mean? Your mass would stay the same no matter what. Potential energy equals, not times. But your mass would be your 55 kilograms. Gravity, no matter what, if you are on Earth, gravity equals 9.8 meters per second squared. That would be your acceleration. If all of a sudden you were to drop off there, you'd accelerate at a speed of 9.8 meters per second squared. So every second you would increase your speed or your velocity by 9.8. Now, what does that mean in regards to this? Well, that's your gravity. It'll always be 9.8 on Earth. It might change on other planets, but on Earth, which is all we're doing today, it will be 9.8 every time. So now you have your mass of your Spork Knife character, your gravity, and your height. Think about it. Height here, let's just say that they're 20 meters off the ground. So 20 meters is about 60-some feet for those of you living in the States. Now, you're 20 meters off the ground as your height. How does that relate to our equation? Mass times gravity times height. Well, Mass times gravity times height, you literally just plug the numbers in. So you go 20 times 9.8 times 55. So if you brought all these numbers in, you would get a potential energy of 10,780 joules. So if someone were to say take a weapon and break off the bottom of that ramp you just built, you would fall and you would gain the energy by the time you hit the ground of 10,780 joules. I'm pretty sure no matter how many chug jugs you drink, you're not going to survive that one. That is how you calculate potential energy. It would be the same for this. That is gravitational potential energy, though. The spring is a little bit different, but we're not going over that today. We're just going over gravitational. So remember, kinetic is moving. It's motion. Potential is position. If you keep that in mind, you will be just fine. Kinetic is your 1/2 times mass times velocity squared. Potential is your mass times your height times gravity, which is always 9.8 on Earth. I hope this helped you so you can kind of get through what you need to get through, and maybe you did learn something new today if you didn't know before. So if you did learn something new, or if you have any questions, please leave a comment down below. And be sure to like the video so you can come back to it at any time a lot quicker than having to put it in your search bar every time you want to come back. And as always, subscribe for more content, and also so you can find the channel a lot easier if you like these videos whatsoever. So thank you again for coming and listening to my little lecture on kinetic and potential energy. I hope you had fun, and I will see you next time.